Hi, everybody. I got a quick email today from Renee asking me if I could make a short video about mins and maxes, relative, global, absolute, local, a couple different names for them, and about even and odd functions. I think I might split that into two videos. We'll see. But I'm always happy to do that. You guys send me an email. You want a little quick video on something? I love to do that. So let me know if you have any of those. So, mins and max. It seems like it should be a real straightforward idea, but it's actually got some complication to it. And it's one of those things that the book has a hard time with. It's a tough thing to write out in words. It's a lot easier when you can draw stuff and point at it. So it's a nice topic for us to talk about. So I'm going to draw a little graph here. So we have a little graph. It looks like it's probably a polynomial. Not necessarily true, but looks like it's probably a polynomial. So if we want to talk about mins and maxes, there are two different types of mins and maxes. First off, if we talk about maximums, we're always talking, when we talk about mins and maximums, about the function values. The function values. So we're talking about minimum y values or maximum y values and the x's that cause them to happen. So if we want to look at where the maximum y value is, well, this point here seems to have the highest y value of any other point on this graph. Because it's the highest of any of them, it's often referred to as an absolute max. Because it is absolutely the maximum value for any other point on that graph. Sometimes you'll hear it referred to as global max. That's not how you spell global. Sorry. But anyway, sometimes you'll hear it referred to as global because it's globally for all of the values the maximum. Now, this point over here is certainly not the maximum value of the graph anywhere, but notice it is the highest point in a little relative area around it. So it's not the biggest person anywhere, but it's the biggest person in that room. So this isn't a global maximum or an absolute maximum, but it is a maximum for a little neighborhood around it. So it's still referred to as a maximum. It is just a relative maximum, sometimes called the local maximum, because it is the highest point in its little place. Similarly, this point down here is not the lowest place anywhere on the graph. These points certainly have lower lower y values, but it is the smallest value in its little neighborhood. For this x value here, call it x1, for the x's around that x1, this is the smallest value you will get in that little neighborhood. And again, the word neighborhood is actually a technical term for a little bubble around a value. So while it's not the absolute minimum, it is a local minimum. Again, often referred to as relative. You can use those words relative and local interchangeably, just like you can use the absolute and global interchangeably. So hopefully that explains a little bit of the distinction between local and absolute. A couple more details though. Notice this graph keeps going down and down and down. There is nowhere on this graph where it has an absolute minimum value. For any value here, it's always going to go lower. If you go lower than that, the graph can always get lower. So there is no lowest output this graph is going to get. So there is no absolute minimum, no global minimum. So you don't always have both absolutes and global maxes and mins. Another example If we look at a graph that has endpoints on it, let's say that one, and it's got nice little closed endpoints on it, so it doesn't have the arrows that say it keeps going. This has a couple of maxes on it and a couple of mins on it. Certainly, this is the highest y value that ever occurs. So that is a global, I always like absolute. That is an absolute max. This is the lowest y value that we ever see. So that is an absolute minimum. This is not the highest value everywhere, but it is the highest value in a little neighborhood around it. So this is a relative or local, I'll use relative, maximum. But we have to be careful about that endpoint. That endpoint is certainly not the absolute minimum, because we do have lower values. And it would be tempting to call this point a relative minimum, but we have to be very careful. If we kind of zoom in on this, to be a relative minimum, you have to be smaller than everything on both sides. This is certainly smaller than everything on this side, but there are no values on the other side. So in a very technical way, we can't make the argument that it's smaller than everything on both sides, because we're not defined on this left side. That might seem very technical, but our definition for relative minimums and maximums is a very technical definition. So endpoints like this, like that, can never be relative or local maxes and mins. They can be absolutes, because they can be the largest value we ever see, but this is not also a relative max. By the way, this point down here, this absolute minimum down here, it's also the minimum in everything in its little area, so this is also a relative min. But be careful about thinking that all absolute minimums are relative mins, because like up here, this absolute maximum is not a relative maximum because it's not defined on both sides of the point. So that's a more subtle point. It mostly becomes important when you start talking about calculus. I want to add into this discussion on max and mins. I said I'm going to make the even and odd a different video, but it's a nice time for us to talk about the idea of increasing and decreasing. It's fairly natural when you talk about where the function is increasing and decreasing to see, since this arrow is going down, to think of this as part of the graph that's decreasing. Since this arrow is going up, to think of it as values that are increasing. But we have to be careful about that. When we talk about where the function is increasing and decreasing, we really are asking for what x values are the y values increasing or decreasing. Furthermore, x values as x goes left to right. So as x increases, as x goes from negative values and increases, as x is increasing, what's happening to the y values? So as our x values go in this direction, here our y values are actually going up and up and up and up and up until they reach this relative max. Let's say that relative max happened at -4. that would mean we are increasing from negative infinity, as far this way as you want to go, assuming this continues downward. We'd be increasing all the way until negative 4. At negative 4, at that peak, we're neither increasing or decreasing. And then we would be decreasing, our y value is going down, until we get to whatever that value is. I'm going to call it 5. So we'd be decreasing from negative 4 to 5. Then notice we start increasing again. And we increase from that 5 on. So this interval unioned with, it's a nice use of the union symbol, from 5 to infinity. So we're increasing over both of these. So we're increasing from negative infinity to negative 4 and from 5 to infinity. And we're decreasing from negative 4 to 5. It's a little bit silly, but I often like to think of a little hiker, somebody who's hiking up this, they have a walking stick apparently, who's hiking this hill. They're going in that direction, just like the direction that we read, and where are they going uphill is where we're increasing, where they're going downhill is where we're decreasing, uphill, increasing. So hopefully that helps. One last bit of vocabulary. These are still our relative min, relative max. If you're trying to find a global min or max on this problem, or an absolute min or max, it doesn't have one. There's no point for which you can't go higher, because this is going to keep going up and up and up. So no absolute max. Minimum, this is going to keep going down and down and down, so there's no value for which you can't be lower. Positive and negative infinity don't work as maxes and mins because they're not actually numbers. So no absolute max or min on this at all, just a relative max and a relative min. The word extrema you'll see thrown around. That word extrema is all relative and absolute maxes and mins. So in this graph, the extrema would be this point, a relative max, this point, a relative min. For that first graph we had, the extrema would be this relative max, this relative min, this absolute and relative maximum. So be careful about, a lot of people associate the word extreme with just large values. It's your large and small, global and relative max and mins. Well, hopefully that helps. If you have any questions about that, please let me know. And again, I'll put up a video for even and odd functions. And if there's anything else you want me to make, let me know. I'm happy to do these. I like to have a set of these I can post for you guys.